In this video, we're going to talk about unusual functional groups, in addition to the regular ones as well. So the first one we're going to talk about is a very common one. This is an alkane. It's a hydrocarbon, it's saturated, it's filled with hydrogen, and it has the formula C5H12. This is pentane. This is a cycloalkane because it forms a cyclic shape. This is an unsaturated alkane. It's not filled with hydrogen. The chemical formula for cyclopentane is C5H10. Notice that it has 2 hydrogen atoms less than pentane. So the IHD, the index of hydrogen deficiency, is 1. Anytime you have a ring, the IHD will be 1. This is called a bicycloalkane. Bi means 2, since we have 2 rings. Now, because we have 2 rings, the IHD is 2. In addition to cycloalkanes, alkenes are also unsaturated hydrocarbons. For every double bond, the IHD will be 1. So that's an alkene. This is a diene, or you can also call it an alkadiene. Di means 2 since we have 2 double bonds. The IHD for this molecule is 2. This is also known as a conjugated diene. Whenever you have alternating double, single, and double bonds, you have what is known as a conjugated diene. This here is an alkatriene. It's also a conjugated diene. A conjugated alkene. Now, sometimes you'll have double bonds right next to each other. This is known as accumulated diene, which also has a special name, allene. If the double bonds are far apart from each other, where they're not conjugated, this is simply known as an isolated diene. Now, whenever you have a triple bond, you're dealing with an alkyne. If the triple bond is in the middle of the chain, it's an internal alkyne. If it's at the end of the chain, it's called a terminal alkyne. The IHD, the index of hydrogen deficiency for a triple bond, is 2. This is benzene. The functional group is an aromatic ring. This is also known as an arene. The IHD, what do you think the IHD for benzene is? We have a ring, 3 double bonds, that gives us an IHD of 4. So if we were to compare that to hexane, which has 6 carbons, 14 hydrogens, we could determine the number of hydrogens on this. Every time you have an IHD of 1, that means you have 2 less hydrogen atoms than the number of hydrogen atoms in a saturated alkane. So the maximum number of hydrogen atoms that could be on 6 carbons is 14. With an IHD of 4, 4 times 2 is 8, 14 minus 8 is 6. So the chemical formula for benzene is C6H6. Now, when benzene is on a very long carbon chain, it's going to become a substituent. As a substituent, it's called phenol. In organic chemistry 2, you're going to learn about this intermediate. This is called the benzyne intermediate, and it's typically found in nucleophilic aromatic substitution reactions. So think of a benzene with an alkyne functional group inside of it. So it's called benzyne. Now let's talk about alcohols. So this is an alcohol, particularly it's a primary alcohol because the OH group is on a primary carbon. The reason why this carbon is primary is because it's attached to one other carbon atom. Secondary carbons are attached to 2 carbon atoms. Tertiary carbon atoms are attached to 3 other carbon atoms. So that's a primary alcohol. This is known as a diol, particularly a cis diol. So the word di means 2. We have 2 hydroxyl groups. This is called a thiol. Whenever you see the prefix thiol, think of sulfur. Now in Gen Chem, you know OH minus, this is hydroxide. In organic chemistry, you're going to see something similar. And this is called, it's like a strong base, just like hydroxide, but it's called alkoxide. So instead of OH, what you have is OR. But both are strong bases. Now, if OH is hydroxide and OR is alkoxide, what do you think SR negative is? You deserve 20 bucks if you can guess the right answer. This is called a thiolate ion. I would be very surprised if you got that right. So that's the thiolate ion. This is an ether. It's abbreviated ROR. What do you think this is if we replace the oxygen with a sulfur? And we get the group RSR. What is that called? This is called a thioether. It's also called a sulfide, an organic sulfide. Now, what if there's 2 oxygen atoms instead of 1 between the carbon chain? What do we have here? So this is no longer called an ether. It's a completely different class of compounds. This is called an organic peroxide. It's highly reactive. Now, what if we replace the 2 oxygen atoms with 2 sulfur atoms? What do we have now? This is called a disulfide. So if this is a sulfide, this is a disulfide, or an organic disulfide. Now typically you'll see these disulfide bridges whenever you have the oxidation of a thiol group. So cysteine is an amino acid with a thiol group. When 2 cysteine molecules get oxidized, they will form a disulfide bridge. So typically you'll encounter that functional group in maybe biochemistry when you go over amino acids. Now I'm pretty sure you've seen this in your bathroom or something. This is H2O2 and it's hydrogen peroxide. Hydrogen peroxide, along with the organic peroxides, they're typically associated with radical reactions in organic chemistry. Now, what if we have a 3-atom ring with an oxygen? What do you think that is called? This is called an epoxide. It looks like an ether, but it's in a ring instead. If that is an epoxide, what is this? So this is called an arene oxide, also known as benzene oxide. Now, instead of a 3-atom ring, you can have an oxygen in a 4-atom ring, 3 carbons and 1 oxygen. If you see this, this is called oxetane. Now, sometimes you'll see this where there's an oxygen. There's 2 oxygen atoms in a ring. So we have 4 carbon atoms, 2 oxygen atoms. This is called an oxane, specifically a dioxane. Now the oxygens, they're 1,4 apart. Let's say this is atom 1, 2, 3, 4. So this is specifically called 1, 4 dioxane. Now, what's going to happen if we replace the oxygen with a sulfur in the epoxide functional group? What do you think this is going to be called? This is called thiirane. We have that special prefix. We don't have the thio part, but we do have thi. Now, there's another special class of cyclic ethers that I want to discuss. If you're taking Organic Chemistry 1, you're going to see it when you go over SN1, SN2 reactions. So this is called a crown ether. Specifically, this is called a 12 crown 4 ether. There are 12 atoms in total, 4 of which are oxygen atoms, and 12 minus 4, the remaining 8 are carbon atoms. Now you do have other categories of this type of ether. What I'm going to draw is the 15 crown 5 ether. So that's the 15 crown 5 ether. There are 15 atoms in total and 5 oxygen atoms. The 12 crown 4 ether is very useful for solvating lithium ions. The 15 crown 5 ether, it's bigger. It can solvate a bigger ion, in this case the sodium ion. And the 18 crown 6 ether is used to solvate the potassium ion. So now let's move on to the next one. Let's talk about this functional group. So we know this is an aldehyde. Anytime you see a CHO functional group, you know you're dealing with an aldehyde. This here is a ketone. The aldehyde has 1 R group. The ketone has 2 R groups. The aldehyde has the hydrogen at the carbonyl functional group. So here's a question for you. If this is an aldehyde, what is that? And if this is a ketone, What is this? So this is still an aldehyde. It also has a special name, an alpha beta unsaturated aldehyde. This is the alpha carbon, that's the beta carbon. The double bond is between, the alpha beta carbons, so it's an alpha beta unsaturated aldehyde. But it also has another name. It's known as an enol. And it makes sense because here we have an aldehyde and we have an alkene. Whenever you're naming an aldehyde, it ends in al. So for instance, this 4-carbon aldehyde is called butanol. So notice the suffix al. That tells you you're dealing with an aldehyde. Whereas if you're naming an alkene, this is 1-butene. So ene is for the alkene. Here we have an alkene and an aldehyde, so it's called enol. So if that's the case, what do you call this one? So we have a ketone with an alkene. This is called an enone. Alkene plus a ketone, enone. It's also an alpha beta unsaturated ketone. Now, if this is an aldehyde, what do you call this? Let's say if we replace the oxygen with a sulfur, what do you call it now? So while you're thinking of that one, I'm going to write up a few more. Go ahead and identify the functional groups if you know what they are. So on the left, instead of an aldehyde, what we have is a thiol. So if you recall, a thiol is an SH group. So like an alcohol, but there's thi and then ol, ol. Here, instead of the ol for thiol, since we have an aldehyde we have al instead. So thiol. They kind of sound similar, thiol, thiol. It's kind of hard to differentiate them, but the difference is an A instead of an O. If this is a ketone, what is that? This is called thioketone. So that one is easier to remember. Now, if we replace the carbon with a sulfur, but keep the oxygen there, what do we have now? So it's not a thioketone, it's something else entirely. This is called a sulfoxide. And if we have 2 double bonded oxygens on that sulfur, this becomes a sulfone. Not cell phone, but sulfone. Now, we know this is an alcohol. Particularly, this is a secondary alcohol because the OH group is on a carbon that's attached to 2 other carbons. So that makes it a secondary alcohol. This is an amine. Now, it's not a secondary amine, it's actually a primary amine. With amines, it's determined differently. For alcohols, they're always attached to 1 carbon atom. So the type of alcohol is determined by the type of carbon atom it's attached to. When you're dealing with amines, the nitrogen can be attached to 1 carbon, it could be attached to 2 carbons, it could be attached to 3 carbons. So the type of amine is not determined by the type of carbon it's attached to. It's determined by how many carbon atoms the nitrogen is attached to. So for instance, what type of amine is this? Is it primary, secondary, or tertiary? This carbon atom is secondary. This one is primary. Do you say it's primary or secondary? So it doesn't make sense to look at the carbon atoms. In this case, you look at the number of carbon atoms attached to the nitrogen. So this would be a secondary amine. This is a primary amine because the nitrogen is only attached to one carbon atom. So the rules are different when you're looking at amines and alcohols, when you're determining if it's primary, secondary, or tertiary. Now, if this is an alcohol, what type of functional group do we have here if we put a double bond right next to it? And if this is an amine, what is this? So while you figure that out, I'm going to draw some more structures. If you know what the other ones are, feel free to mention it as well. So instead of an NH, this is going to be an NOH. So here we have an alcohol functional group and an alkene. If we can combine all with ene, we get an enol. Here we have an amine with an alkene. Combining those two, we get enamine or enamine. Now, if you have a carbon double bonded to an N, instead of an enamine, this is called an imine or an imine. This is called an oxime. I will be very surprised if you got that one, if you've never seen it before. Now, this is very familiar. This is a carboxylic acid. Now, what happens if we replace the OH group with a chlorine, or if we replace it with a bromine? What do we get? So this is called an acid chloride, and this is called an acid bromide. If you put them in water, they will generate a carboxylic acid. This will be replaced with the OH group. Now, what do you think this is? So instead of RCOOH, which is also RCO2H, you'll see this as RCO3H in orgo 1 and orgo 2. So if you remember this functional group, this was an organic peroxide. And here we have a carboxylic acid. So when you combine those two, you get a peroxy acid. So combine peroxide with carboxylic acid, peroxy acid. So anytime you see RCO3H, you're dealing with peroxy acid. Now, what's going to happen if we replace the oxygen with a sulfur atom? What do you call this? And what if we switch these two? What would you call that functional group? Now, what if we kept this the same and replaced that carbon with a sulfur? What would you call that? And what if we add another double bonded oxygen to that sulfur? So what are the names of these different functional groups? So let's start with this one. Actually, these two, they have very similar names. They're both called a thio thiocarboxylic acid. You can refer to both of them as a thiocarboxylic acid. So if you see this carboxylic acid, just add thio to it. But how do we differentiate between these two? So no, the one on the left is called a carbothioic S acid. The acidic hydrogen is on the sulfur. The one on the right, it's also called a carbothioic, but instead of an S acid, it's called an O acid. The acidic hydrogen is on the oxygen. But they're both known as thiocarboxylic acids. Now, this is not a thiocarboxylic acid. That's something else entirely. This is called a sulfinic acid. And this one is even stronger. This is called a sulfonic acid. Sulfonic acids are strong acids. They have a pKa in the negative range. Depending on what the R group is, the pKa can be like -2, sometimes even as high as -7 for TSOH, para-toluene sulfonic acid. In contrast, a carboxylic acid typically has a pKa of around 4 to 5 if there's no electron withdrawing groups attached to it. If you add an EWG to it, the pKa could drop to like 2 to 3 for carboxylic acid. What if we replace both oxygen atoms of a carboxylic acid with a sulfur? What is that called? And what if we don't have the double bond O on the sulfur? What if we just have that? What would you call these two functional groups? So this one, it's still similar to a carboxylic acid because oxygen and sulfur, they're in the same group. They're both chalcogens in group 6A. So it's still a carboxylic acid, but it's called dithiocarboxylic acid because we have two sulfurs instead of one. You can also call it carbodithioic acid. Now this one, it's still an acid. We have an OH group with attached to a sulfur. So this hydrogen is still relatively acidic. But this is called a sulfenic acid with an E. So instead of sulfonic acid, sulfenic acid. Now let's move on to esters. So this is an ester. Now what would you call a cyclic ester? What's the name for this type of functional group? A cyclic ester is known as a lactone. Now, what if we replace the OR group with an SR group? What do we get there? And what if we replace the double bonded oxygen with a sulfur? How does that change it? So feel free to think about those in the meantime while I draw a few more functional groups. Both of these functional groups are known as thioesters. The one on the left, I've seen it referred to as thiol thioester. And the one on the right, I've seen it referred to as thioester. But they're different categories of thioesters. So if you see ester, just add a thiol to it. Now, what do you think this is? Because we're talking about esters, you know it's a type of ester. This is a sulfonate ester. Remember, if we replace the OR with an OH group, it becomes a sulfonic acid. So switching the OH with an OR group, it becomes a sulfonate ester. On the right, what we have here is called a phosphoester. Now, you'll typically encounter You'll typically encounter phosphoesters in biochemistry when you're studying DNA. Phosphoesters, they're found in DNA molecules. It's the bond that connects the phosphate group to the ribose sugar. Now, let's move on. So what we have here is, as mentioned before, an amine, but particularly a primary amine, since the nitrogen only has one carbon attached to it. Now, what happens if we add a carbonyl group to the amine? What does this become? So this is a familiar functional group. You know it to be an amide. Now, what do you call a cyclic amide? Let's say if it's part of a ring system. What is it now? Cyclic amides are known as lactams. So instead of lactones, which are cyclic esters, lactam, like think of amide, those are cyclic amides. Now looking at the amide functional group, what happens if we replace the double bond O with a double bond N? What is this? This is called amidine or amidine. It's kind of similar to an imine, but instead of this being a hydrogen or an R group, which will make it an imine, the R group is an NH2. So that's the difference between an imine and an amidine. Now, what if we added another carbonyl group to the amide functional group? So where the nitrogen is in the middle. What is that? Notice that it looks very similar to this. So if it's an oxygen in the middle, this is called an anhydride. But if you have a nitrogen in the middle, this is called an imide. Very similar to an amide, but you just have two carbonyl groups instead of one. So that's an imide. Now let's compare the imide with other functional groups. I'm going to redraw it. So that's the imide. What do you think this is? So we have one carbonyl group with two nitrogens attached to it. That is a carb amide. A good example of that we have in nature is urea. So urea is a type of carb amide. if we were to replace the oxygen in urea with a sulfur group, this becomes thiourea. So urea is a carbamide, that's the functional group for that. Now what if we replace one of the NR2 groups with an OR? Let's make this a different color. What does it become now? So while you're thinking about that, I'm gonna write up this one. So what if we replace both NR2 groups with OR groups? So this is a carbamide. This one here is a carbamate with an M ester. This part here, you can see, is the ester part. And this part looks like the amide part. So carbamate with an M, AM, ester. Now this is not going to have an M in it. This is carbonates instead of carbamate. So we have an N instead of an M, but it's also an ester. We can see this side looks like an ester. So that's the difference between a carbamide, a carbamate ester, and a carbonate ester. Now what do you think that group is called? And let's compare it with this one. So with the NO2 group attached to a carbon chain, that's the nitro group. If it's NO, this is the nitroso group. So this is how the nitro group looks like. It's an R with a nitrogen attached to a double bonded oxygen and a single bonded oxygen. This oxygen has a negative formal charge. The nitrogen, because it has 4 bonds, has the positive formal charge. In a nitroso group, it looks like this. You have a nitrogen double bonded to an oxygen, and it has a lone pair. The nitrogen is neutral. Now what do you think this is? O and O. This is nitroso oxy. So we have an oxygen in between the carbon and the nitrogen. So the nitrogen is not directly attached to the carbon atom, as in the case of the other examples. So it looks very similar to the nitroso group, but there's an oxygen between the carbon and the nitrogen atom. So that's nitroso oxy. If you see N3, this is azide, and it looks like this. So you have 3 nitrogen atoms. The nitrogen in the middle doesn't have a lone pair. The one at the end has a negative formal charge. The one in the middle has a positive formal charge. So that's the azide ion. Now if you see R, N2, this looks like this. Think of nitrogen gas. This nitrogen has a positive formal charge. Now the next one is the azo group. It's N2 as well, but between 2 R groups. So that's the azo functional group. Now, what is this functional group called? This is a very familiar one, so you should know this. And let's add an oxygen between the R group and the carbon atom. And what happens if we switch the nitrogen with the carbon? With the oxygen. Let me draw a little different. So on the left, this is known as nitrile. In the middle, this is the cyanate functional group. And on the right side, this is isocyanate, when we switch the nitrogen and the oxygen. Now, with that being said, what would you say for these functional groups? For the nitrile, what happens if we switch nitrogen and carbon? What do we get? The nitrogen is going to have a positive formal charge. The carbon will have a negative formal charge. So they won't be neutral in the case of the nitrile functional group. Now, in isocyanate, what if we replace the oxygen with the sulfur? It might be more accurate to draw this way. What do you call that? And for isocyanate, what if we replace the oxygen with the sulfur atom? What will be the name for that new structure? So on the left, instead of nitrile, this becomes isonitrile. We switch the carbon and the nitrogen. Now, instead of cyanate, this is called thiocyanate. And instead of isocyanate, this is called isothiocyanate. So those are some additional functional groups that you want to be familiar with. Now we know this is an alcohol. And we know this is an alkyl halide, specifically an alkyl chloride. You could have alkyl bromides, alkyl fluorides, alkyl iodides, but this is an alkyl chloride. Now what happens if we combine those two groups into one? Let's say we have a chlorine atom and a hydroxyl group adjacent to each other. So this particular molecule has a special name. It's called a halohydrin. It's when you have an alcohol and an alkyl halide right next to each other. Now, what about if we have a CN group and an OH group? So we have an alcohol and a nitro group on the same carbon. What do we call that? So instead of halohydrin, this is called a cyanohydrin, because we have a cyanide group instead of a halogen. So the suffix doesn't change, hydrin. I think of like something hydrated like water. The OH group if you add a hydrogen to it, it becomes water. But here we have like a haloalkane or a halogen. Here we have a cyano group. So that kind of helps you with the naming. Now, what if we have an NH2 group with an OH group on the same carbon? What is that called? This is called a carbonyl amine. So carbonyl for the alcohol and then amine for the NH2 group. And what would you call this? Let me draw that better. Let's say if there's two OR groups on the same carbon. What's the name for that? Here we're still going to have the same two OR groups, but there's going to be a hydrogen instead of an R group here. So this looks like an ether, carbon, oxygen, carbon, but because the OR groups, there's two of them on the same carbon, it has a different name. This is called a ketal. It comes from a ketone. This is called an acetal. It comes from an aldehyde. But sometimes this may be called acetal. So when you see this, just know this is a ketal, this is an acetal, but sometimes both are commonly referred to as acetals. The word acetal is used more often than ketal. So I want you to be aware of that. Now, instead of two OR groups, what if we have an OH and an OR group? What would you call that? And what if we replace the R group with a hydrogen? What happens then? So this is called a hemiketal. When I think of the word hemi, I think of like hemisphere, half. So we have half of an alcohol group and half of an ether group. So it becomes a hemiketal. And this is a hemiacetal. Now, what if we replace the OR groups with sulfur atoms instead? What happens? Sometimes the R groups can be connected, and you can get like a protecting group. These two are very similar in terms of functional groups. The only difference here is the hydrogen and the R group. This needs to be an O. So all we got to do is add thio to this. This is a thioketal, and this is a thioacetal. This is a thiohemiketal, and this is a thiohemiacetal. What if we have two hydroxyl groups on the same carbon? This is a diol, specifically a gem diol. This is a vicinal diol because they're on adjacent carbons but not the same carbon. Now let's go back to carboxylic acids. So that's propanoic acid. If we add a hydroxyl group to this carbon, what do you think this is going to be called? So this becomes an alpha hydroxy acid. Here we have butanoic acid. The first carbon is the alpha carbon, the second carbon is the beta carbon, the third one away from the carboxylic acid, that's the gamma carbon. So the hydroxyl group is on the alpha carbon, so it's an alpha hydroxy acid. Perhaps you've heard of it as AHA. This is used in lotions, particularly for the purpose of exfoliation. There's also BHAs. So if the hydroxyl group is on the beta carbon, what you now have is a beta hydroxy acid. In other words, BHA. AHAs are more acidic than BHAs. When I looked it up online, according to Wikipedia, the pKa for this was around 3.9, and for this one it's 4.5. When the hydroxyl group is closer to the carboxylic acid, it's going to make this OH group more acidic. Propanoic acid has a pKa of 4.9. So AHAs are more acidic than BHAs. They have a lower pKa value. This particular AHA is called lactic acid. So now you know the difference between alpha hydroxy acids and beta hydroxy acids. What would you call this functional group? And let's compare it to this one. So here we have a ketone and a ketone. So you can call that a diketone. But it also has another name, a beta diketone. So relative to this ketone, the other one is on a beta carbon. This will be the alpha carbon, this is the beta carbon. So it's a beta diketone. Now, the ester has more priority than the ketone. So relative to the ester, the ketone is on the beta carbon. So this is called a beta keto ester. What would you call this functional group? And let's compare it to this one. So here we have a carboxylic acid and we have an amine. So when you combine a carboxylic acid and an amine, you get an amino acid, which are the building blocks of protein. This particular amino acid is called alanine. But notice that the NH2 group is on the alpha carbon, so this is alpha alanine. Now what do you think the other one is called? By the way, the majority of amino acids out there are alpha amino acids. This one is a beta amino acid. I put alpha instead, but notice that the amino group is on a beta carbon. So it's a beta amino acid. Specifically, this is known as beta alanine. Now the body actually uses beta alanine along with the other amino acid histidine to make the dipeptide carnosine. Carnosine is found in foods, and foods like meat, chicken, and stuff like that. But that's beta alanine. It's an unusual beta amino acid.